click record. I'll give you a second.
Yep, got it.
All right, thanks. All right, everybody, welcome to this latest installment of the LC University. Good morning. I see people texting already. So welcome again. My name is Jeff Hageman. I'm the Technical Service Manager here at Liquid Controls. I think most of the names I see are familiar here that are popping up for the training today. So that's great. I'm so glad so many of you can continue to attend with us every week. We really do appreciate it. Today, we're obviously covering calibrations. So we're going to be covering calibration of mechanical meters and then talk a little bit about gear plate selection for the first part of the discussion today. That's going to be led by our technician, Tom Planowski. Most of you are familiar with Tom. He's done some of the other mechanical training here for us in the past classes. And then Bill Westwell is going to join us after that and talk about how to do calibrations on our primary electronic registers, the LCR family, so the LCR2, the LCR 600, and then also the IQ product as well. So we'll be covering all those today. A little bit of housekeeping again. The next two classes, so next week, I'm sorry, not next week, July 7th, so 2 weeks from today, is going to be the next class, and that class is solely going to be focused on mechanical meter and accessories. So we're going to be talking about, you know, the different accessories such as strainers. Strainers. So we'll be covering strainers, aerometers, valves, things like that. All the different accessories that are available on the mechanical meters. And I believe in talking with Tom today, it's going to be primarily a video conference, so he'll be showing live demonstrations of all those pieces and fitting them onto the meter so you can see how that goes together. So again, that's July 7th. And then after that, the next class, the last one in this first part, this first series, will be July 21st. And that's going to be covering the LCR 600 product. So installation, setup, operation of the LCR 600. So hopefully everybody can join us for those upcoming classes. And without any more discussion, a couple things again. Please, as we go through, we'll try and pause periodically during the class so people can ask questions. If they want to unmute at that time and ask questions, feel free. Always know that you can also do the chat feature that's on Teams. So if you hit the button for doing the chat, you can send us a message and we can try and answer those through the chat as well. Or if it's a question we want to actually discuss, we'll bring that up in the discussion as well. So please know that we're here. And if you're not comfortable asking a question in this environment, you know that you can always contact our technical services team at any time. So with all that being said, we're going to go ahead and kick this off. So I'm going to go ahead and hand things over to Mr. Tom Planowski, and he's going to walk through the mechanical calibration side of things. So let me just on spotlight here. All right, Tom, you should be able to take control now.
All right. Let me see if I can share my screen to start with. Sure, why not?
Are you able to hit the share content button?
Yeah, I am, but it's not switching at the moment. Give me 1 second. Give me 1 moment. I don't know what I'm not sharing. All right. Can you see it, Jeff?
I can see it.
Yes. Okay.
Yeah, you're not in presentation mode, but I can see your I can see your
yeah.
PowerPoint.
Is that better?
That looks great. Thank you.
Okay. All right. All right. Again, good morning, good afternoon, guys. My name is Tom Planowski, and I'll try to walk you through a mechanical meter calibration and some concepts related to it. Let me. I don't know why I lost my. Jeff, can you see still?
We can see your screen there, Tom.
We can see,
Yeah,
okay, because I lost my screen on my own. Okay. So, a training agenda for today. We'll start with some simple concepts of accuracy, repeatability, linearity, and reproducibility. Move over to some of the principles of calibration and really measuring, including things like calibration intervals. We'll look at a specific meter configuration, meter with mechanical registers, and we'll focus on things like packing glands, packing gland ratios, adjusters, and gear plates. Then we'll follow with making actual adjustment of mechanical register and different methods of calibration. What is calibration? It's really a process or a procedure of setting or bringing a meter into agreement with an established standard. The standards are different across the world. There could be a NIST standard as far as United States. It could be a Measurement Canada, and those standards are established in Canada, or IML standards or other standards across the globe. So the bottom line is we're trying to adjust the meter to make sure that it meets those established standards. But before we get to actual calibration, let's take a look at the basic definitions and basic really characteristics of the meter, which is accuracy, repeatability, linearity, and reproducibility. This is the parameters you're going to be really looking at when you're calibrating a meter. One of the easier way of explaining those concepts is really using a concept of a target. If you look at a target, either you're shooting a rifle or shooting a bow and arrow or throwing at darts, the concept will be exactly the same. If you look at this a screenshot here, it shows precision with accuracy. Really, this target really shows all the shots being in one cluster right in a bullseye. That's really a definition A of accuracy, because we're hitting a bullseye every time. And at the same time, it's a definition of repeatability, which is really a precision part of this description. We're hitting precisely in one cluster every time. So what this target represents is accuracy with repeatability. If you look at the next target, we call it a scatter. This one demonstrates what maybe on average not a bad accuracy. You're still hitting the center part of a target, but definitely those shots are not in one cluster. So this doesn't really, it's not a repeatable shooting. We're being a little bit more all over the place. We're scattered, we're not precise. And a third one, it really shows two different pictures of precision, but not accuracy. We're not accurate because we're not hitting a target, we're not hitting a bullseye every time, but we're very repeatable. All the shots are in the same cluster on both of them. Now, if we're shooting a rifle, obviously you can adjust it and start adjust either manually or adjust the sight on your rifle. That's going to bring the rifle and bring your shots closer to the bullseye, which would be a process of calibration. And that's really what we're going to look in the process of calibrating a meter. Meters coming out of the factory are tested. We know they meet the standards they're designed to meet. But on the field, they will be operating in different conditions with the different pump systems, different valves, different liquids. What we're looking in a meter in general is repeatability. Repeatability is really precondition for meter to being accurate. Because if we look at those clusters of precise shots, all we have to do is take those clusters and shift over to the center, which will provide us with not only repeatable, but also with accurate unit. Now, linearity is the third concept. It's linearity, it's really accuracy also, but instead of being accuracy at a single point, let's say it's your high flow rate of the meter, linearity is accuracy of the meter throughout the range of the flow. If we look at the meter, let's say our M7 meter, class 1 meter, is generally rated for 10 gallons a minute as a minimum and 100 gallons a minute as a maximum. If we test this meter across the range of flow, and that meter is accurate within setup parameters or expected parameters, that meter will be linear or accurate throughout that range. If we test the meter throughout the range of flow at the different flow rates, different points, we'll be able to plot those points and create what's called meter curve. Meter curve, and that's example of a meter curve, MA7 meter, tested between 20 to 100 gallons a minute. And that, again, that's a typical meter curve of a liquid controls meter. Calibrated or at 100 gallons a minute, that's where the meter is zeroed out. That has its most accurate point, and then tested at the different points, and those points are plotted to represent the curve of that meter. Now, we'll look also at a few more curves here. Those curves will show different test points, but also they're showing targets representing repeatability of that meter at those specific points. So let's say the first one is at 600 gallons a minute. So it's a little bit larger meter, and there's a target representing repeatability of that meter at that flow rate. Again, if you look at overall curve, you're going to see a few things here. First of all, if you look at each point, the meter is repeatable at every point. You see the clusters of the points, they're close together, so the meter is repeatable. That's definitely what we're looking for. Second, again, meter was calibrated at zeroed out at 600 gallons a minute. So not only that is repeatable, but it's also, you see all the points in a bullseye. So it's repeatable, but it's also accurate meter at 600 gallons a minute. But also what it represents here represents linearity or accuracy across the range of the flow. If you look at high flow and low flow, overall spread between those points is about 0.2%. That's a fairly good meter that meets most of the requirements, most of the standards across the world, being either, again, US, Canadian, or NIST standards. So it's really good meter. And again, the key here is testing at different flow rates, calibrating it at high flow, testing at different flow rates, and really doing repeatability testing at each flow. When you go through that kind of process, you know how good this meter is. Now, we'll look at a little bit of different curve of a meter. Is this meter good? As you can see at repeatability points, each point at each flow rate, those points are pretty repeatable. So that's definitely good. The meter is repeatable. It's definitely repeatable and accurate at high flow. But if you look at the overall spread of that meter between high and low, or one of the low points, this overall spread is a little bit more than 0.6%. That's generally may not be acceptable in all the requirements. So is this meter good? At high flow, yes. Overall total spread is a little bit high. There would be probably a typical curve for a meter that's a little bit older, meter that's been on the field for a long time, and most likely internal is a little bit extended, causing extra slippage of a product through the meter. So even though it's accurate at high flow, it's repeatable, but at the low flow, this meter will not meet the requirements. Again, typical for old meter, a little bit worn out meter internally. Now, This is another curve of the meter. Again, if you look at overall linearity, it's pretty good. It's at 0.2%. But if you look at repeatability of that meter at all the points, that repeatability is not there. That meter is not acceptable. This meter is not acceptable because of its repeatability. Meter cannot be considered accurate if it's not repeatable. And I think the last curve, it's fairly similar, but there are some significant differences. Again, is this meter acceptable? If you look at overall spread of that meter on this curve, it's about 0.2%. So from accuracy standpoint, it's not bad. But first 2 points show to be accurate and also repeatable. But the last 3 points definitely are not repeatable. Even on average, they are accurate. So is there anything wrong with this meter? Most likely not. When you see curve like this, when it's started with very repeatable points and then generally goes into the points that may be accurate but not, or seem to be accurate but not repeatable, that's really indication of the system issue. In most cases, you're dealing with a pump system that is way too much for this meter. So we're generating too much energy to the pump that has no place to go. You're getting to the point that you start chopping up the product, start putting in-train air into the liquid because of all the energy the pump is generating. And you go from meter that is accurate and repeatable to the meter that's not repeatable at the lower flow rates. That happens more in a situation where you're measuring liquid like LPG with a vapor pressure that is a little bit high vapor pressure. So is this meter, is there anything wrong with this meter? No. Is the system as a whole thing acceptable? Not. Because if you start running this meter at the lower flow rate, you will have accuracy or again repeatability issues. So it is really important when you're designing a system to make sure that all the components of the system match each other. So you're not generating too much pressure on the pump, too much energy on the pump, and that energy has no place to go, and then creates issue of on the meter side. Because again, when you're calibrating a meter, when you're testing a meter, you're not testing only meter alone. Meter is really indication what's going on in the system. And if the system is not operating correctly, meter will show that. And that curve illustrates that example. Now, reproducibility is probably a term that's not used very commonly, but it's also important. It is defined as a performance of a meter that is tested on one system, on the same liquid, same pressure, same temperature, but possibly at the different days. That's reproducibility. Can we reproduce the same result from day to day to day? Not from run to run, which is more of a repeatability, but from day to day. Generally, if the meter is repeatable, it will be reproducible. That's a general statement on that. Now, if we summarize all those definitions, again, there are 3 basic characteristics of a meter or meter performance, and they're in order of importance. The most important part is repeatability. The second one will be accuracy at the single flow rate, but also accuracy across the range of flow, which is more of a linearity, and reproducibility as the last one. Again, they're related to each other, but also but they are measured independently. So accuracy may depend on repeatability, but they are measured independently from each other. Again, just a quick definitions. So there on the screen, repeatability means that the meter measures and reports volume that's being delivered precisely the same way on multiple deliveries. Accuracy has 2 definitions. Accuracy at the single point, let's say at our highest flow rate, and that accuracy, if the meter is zeroed out, will equal generally repeatability of the meter. So if we calibrate a meter and meter is exactly at 0, the accuracy will equal repeatability of that meter. Accuracy across the range of flow, which is linearity. Again, it's accuracy across from high to low flow rate. something that's being commonly tested on the field. And again, we talked a couple of times already about reproducibility, what that means. Couple things to remember, that, as I said before, the meter can be repeatable and accurate. Repeatable and accurate. Meter can also can be repeatable and not accurate. Again, there was an example of the meter that was a little bit older. Again, possibly larger clearances, more slippage, where we can calibrate at one single flow rate at a high flow, but it might not be accurate across the range of flow. A meter cannot be accurate if it's not repeatable. So testing, again, in order of importance, repeatability stands as a number one. If you cannot repeat performance of the meter from run to run, you cannot calibrate that meter. The meter cannot be accurate. If the meter repeats at one or two flow rates but doesn't repeat on other flow rates, there's nothing wrong with the meter. The meter is functioning fine, but there's some significant system issue that need to be addressed. Again, often the meter is a messenger of what's going on in the system. If we have, again, issue with a pump size or anything else, or air in the system, whatever the problem is, the meter will indicate that. And the last one is the reproducibility. Again, that's a repeatability in testing across the maybe multiple days. As long as there is no changes made to the system, to the meter, or any devices related to registration, the reproducibility will be there as long as the meter is repeatable. Now, those are just, again, basic concepts related to calibration. And again, when you're calibrating a testing meter, you are testing for those parameters. So how does the liquid controls meter measure and indicates correct value? With a couple of slides, I'll go back to our previous meter training, which was focusing on really design of the meter and principle of operation. It is important to kind of repeat that because that is going to lead us to actual measurement. So for you guys that attended the meeting about the meter principles, you remember that, you know, the LC meter, it's a fairly simple design. It has really a basic measuring element, has only 9 parts. We have housing. Let me just change something might help. We have housing, which is this. We have 3 rotors inserted into this housing, to the bores of the housing, cylindrical bores. We have a blocking rotor, and we also have 2 displacement rotors. On each side of the meter, we have bearing plates, and bearing plates support all 3 rotors. On the end of each rotor, we have gears. On the end of a blocking rotor gear, we have on the end of the blocking rotor, we have a blocking rotor gear. On the end of displacement rotors, we have 2 displacement rotors gears. The gears have only one purpose, is to create a timely relationship between rotors. So when the rotors turn, they are synchronized in their movement. Again, if you were here on the first training, you probably saw this video that when meter is assembled, and if we put this meter in motion, you will see the synchronized movement of the rotors, and it's, again, synchronized by rotors. You can notice that blocking rotor, which is the larger rotor, is turning one direction, and 2 displacement rotors are turning the opposite direction. Now, what happens inside of the meter? Well, when the fluid moves to the meter assembly turns. The fluid moves to the meter because of the pump pressure, or possibly a gravity, or some other ways to move that product through the system. As the product enters the meter, the product is broken into this sections. Those sections, as you can see it probably better on this here, are separated from each other by displacement rotors. And you see the liquid entering and the liquid leaving a meter or being discharged simultaneously. The key here to measurement is the fact that, again, those rotors are inserted into bores. We know volume of the bores. And since we know how much liquid passes through the meter during each revolution of the blocking rotor, we can measure or with accurately determine how much liquid goes through that meter. Again, we know exactly how much liquid moves through the meter per each revolution of a blocking rotor. And how much of a liquid does it move through that each revolution? Well, that will depend on the size of a meter. Bigger the meter, more liquid moves through the per each revolution. This little chart indicates how many revolutions it takes to displace 1 gallon. We can recalculate that into liters if necessary by dividing this by 3.785. So if we look at one of the more common meters, M7, it takes 5.555 revolution of a blocking rotor to displace 1 gallon. If you look at a meter that's much larger, M60 meter, that meter takes about 0.3 or let's call it 0.4 of a revolution to displace 1 gallon. It means that per 1 full revolution, it's about 2.5 gallons. So very significant differences in displacement of a value depending on the size of a meter. And those numbers are really important because either in mechanical registration or later when we cover electronic registration, those numbers, the displacement per revolution will help us to calibrate and correct the meter. And everything used in electronic calculation, or later we'll look at things like gear plates, these numbers are used to calculate, again, correct ratio of the gear plates. Now, as the meter turns, and again, this is still kind of a little reminder from the previous training, is that rotation of internal components of the meter is transferred to outside of the meter through either packing gland that's going to drive gears or by to pulse output device. So we're taking rotation of the internal components and giving a pulse signal directly to some other electronic registration. Now, this may give you this picture might give you a little bit better idea how that really looks inside. This is a cutaway of one of our smaller meters. This is actually M5 meter, shown from the bottom. So we have our blocking rotor with a blocking rotor gear and 2 displacements. And you can see the packing gland coming in with a fork drive and engaging directly with a blocking rotor gear. On the other side of that packing gland, we have a gear. So as blocking rotor turns, blocking rotor gear turns, engages with a packing gland and ultimately turning the gear that's on outside of the meter. The packing gland is designed to contain the pressure. You can see the O-ring here that seals and prevents from product going around the packing gland, and the shaft inside of the packing gland also has a U-cap seal that prevents product from leaking through it. This is probably a little bit another view of the packing glands. Again, this part, the fork, in some meters there will be a blade drive, engages directly with the meter, shaft transfer that movement to outside. On outside of the meter, we have the gears. And you can see on this picture, the gear, packing gland gear, it's right here behind, engaging with what we call a phase gear. Phase gear is sitting on a hex shaft that's going up, in this case to adjuster, or possibly directly to the electronic registration. Now, one part that's extremely important as far as mechanical registration are the ratio between phase gear, which is the white gear, and packing gland gear. Currently, we use 3 different ratios depending on size of the meters, units of measures, etc. And you have 1-to-1 ratio, when our white phase gear is 24 teeth and metal packing gland gear is also 24 teeth. So it's a 1-to-1 ratio. What it means that as the packing gland turns, it transfers 1 revolution of a blocking rotor directly up through the shaft, either to electronic registration or to adjuster. So 1 revolution of a rotor will equal 1 revolution of this shaft. In some of the meters, you're going to see a 2-to-1 ratio, where packing gland gear is smaller. It's only 12 teeth. So again, this one remains 24 teeth. Notice one difference is that it's got a different shape. We changed the shape of that gear to accommodate difference in size of the phase of the packing gland. So we have to move that gear up a little bit to engage with the packing gland gear. And obviously this gear, this ratio would slow down the output of the shaft by a factor of 50%. And the last one used probably the least, because really we use this ratio on our smallest meter, which is M5. It's 3-to-1 ratio, when this gear, packing gland gear, is only 8 teeth. This one again stays at 24 teeth. It's 3-to-1 ratio. It is extremely important to make sure that on the meter that you're using with mechanical registration, that ratio is correct. As you can see, if you go from 1-to-1 to 2-to-1, again, you are changing output by 50%. Obviously, that would affect accuracy, that would affect measurement tremendously. On electronic registers, it's not as crucial. Generally, we use 1-to-1 ratio, and then all the adjustments are being made through register, whatever it's needed. Now, packing gland turns, the shaft turns. We talked about that shaft is, in case of mechanical register, will drive adjuster. We'll talk about adjuster a little bit later. Adjuster is really a device that will allow us the fine tuning of a register. But before we get to the fine tuning of the register, we got to make sure that all the components and all the gearing are right. So we started with a phase gear ratio to packing gland ratio. And then on the bottom of mechanical counter, this one is a counter printer, you're going to find a gear plate. What gear plate is really a set of gears mounted at the bottom of a counter that converts meter output to desired units of measure. And we'll look at different gear plates briefly, but this is one of the more important part of really meters with mechanical registration, making sure that gear plate is correct, because that gear plate will vary, and it will vary depending on a meter size. So you could have a counter in gallons on M7 meter, and you could have a counter in gallons in M60 meter, but they will definitely have different gear plates. So units of measure will also matter. Let's say liters versus gallons, they will have different gear plates. Packing gland ratio will affect gear plate. They have to match with each other. And also, it also depends which components are we driving. Are we driving only counter printer, or are we adding other components like preset, temperature volume compensator, maybe a swivel, and all that will affect a ratio of the gear plate. If we look at a very simple gear plate picture, the gear plate, again, it's a plate with a set of gears. On the bottom of that plate, you're going to see an input shaft, and that input shaft will generally engage with an adjuster, or some people call it calibrator, micro adjuster. Then you have a set of gears that creates a specific output speed, and then you have an output gear, this little bevel gear, and this bevel gear will be engaged in most cases directly with the counter, with a similar bevel gear on the counter. Now, gear plate has 2 gears. Again, in general, there are standard gears. That's the bevel gear, and you're going to see this silver gear. No, you can't see that part, but it will have number 25 on the top. Those are considered as standard gears, and you're going to see them on every gear plate. And there are also change gears. In this case, only 2 of them. They change gears because, well, they change. There are different number of gears, there are different sizes of gears, and a combination of those gears creates a specific ratio, allowing us to drive the counter with the right speed, drive the counter accurately displaying whatever units of measure we're looking for. So we have standard gears, and then we have a change gears. Again, this one is very simple. It has only 2 change gears, but they can get very complicated. This is just a page from actually a manual that shows different combinations that we use. I mean, 2 gears that you saw in the previous picture, we call it pattern 10. We could have a 3 gears, 4 gears, 4 gears in a different configuration. And the most complicated gear, we call it pattern 50, where you're using 6 gears. And again, those 6 gears will be at different sizes depending on counter, meter size, wherever they're being used. So again, gear plates are not simple. There's a lot that goes to it as far as calculating a gear plates, as far as building a gear plates. The good thing is that in most cases, when you order a meter with units of measure that you're looking for on a specific size of a meter, you should get a counter already with a pre-built gear plates. But if you want to learn more about gear plates, I'll show you where to go to look at it. But there's one thing that you have to really, really remember, because this is a common mistake that's being made on a field. In this case, I have an M7 meter, class 1 meter, so petroleum meter designated for diesel, gasoline, that type of a product with a liter counter. This meter with this counter, so this specific meter with this specific counter will require very specific combination of phase gear ratio, 1:1, 2:1, 3:1, and a gear plate. And only combination of this 2 components with this meter in this counter will allow you to count the volume correctly. If you have either one of those wrong, you will not count it correctly. It is common, especially I see it probably more commonly on aviation market, is that where you have possibly 2 meters side by side, 2 meters of different sizes. They both could be measuring liters, they both could be measuring in gallons, but they do have a gear plates that are different. And I see people just grabbing 1 meter from one counter from 1 meter and moving the counter with the gear plate to a different meter of different size. When that happens and you try to calibrate that meter, you will be far off, depending on what that gear plate is. So again, specific meter with a specific mechanical counter in specific units of measure will require specific combination of phase gear packing gland ratio and a gear plate. If you don't have it right, you're not going to be able to ever calibrate that meter. This combination puts you in the range of adjustment that we can make on a calibrator or adjuster, and then you can do the fine tuning. Let's see if I'll show you very briefly. We'll jump on the website. Hopefully that doesn't change our presentation. This is a link to what we call gear plate selection guide. It is on our LC website, and I'll maybe not. Let me bring it up. Just give me one moment, guys. I'll jump to the right manual this way, manual way. Again, this is a list of all our manuals, and one of them towards the bottom, it should be a gear plate selection guide. There it is.
Hey, Tom.
Yeah, can you see it now?
No, we're just seeing PowerPoint.
PowerPoint presentation. Okay, trying to move it over, but I guess it's not. Okay.
When you shared content, did you share your screen or did you share that specific
website.
slide?
Website.
Yeah, if you release control and then go back to the share content and then choose that monitor rather than the PowerPoint presentation, you should be able to just share everything on that screen.
Okay. How about now?
Give it a second. Looks good. Thanks.
Okay. All right. So again, we're on a website looking at a manual. This is a large manual with a lot of information. But again, in most cases, you're going to get a meter that's going to have a right gear plate. But if you decide to, for whatever reason, change the units of measure and you're looking for a different gear plate and you want to find this, you're going to find this in this manual. We will look at it. We had that M7 class 1 meter in a liter. So we'll see if we can find a gear plate that would work for us on that kind of application. Again, this is a large manual with a lot of content explaining a lot of stuff that I already showed you, but also explaining a lot more about calculating a gear plates, spare parts. But one part that will be important for you is there are tables of pretty much most of the gear plates that we make. There are some common gear plates, which I could find right away which one I need, or I can go to a list of all the gear plates. It starts with the M5 meters. We're going to go all the way to M7 meters, and we're going to try the gear plates in liters. As you can see, there's only really one section showing us the gear plates in liters, and it is right here. Again, we're looking for a gear plate for liters in M7 class 1 meter. Now, how do you make sense out of this? There's a lot of options, and sometimes you may have to call us. But as far as there are really 4 gear plates shown for liters. The first one, it shows.
Hey, Tom.
Yes.
Sorry. Hey, just click that little plus sign and zoom it in a couple.
Okay, it's not big enough. Okay, got it. Yep.
Yeah, thank you. I don't know if everybody else has the same problem. That looks good right there.
Sure. Yeah, it's so again, you see the section for liters. The first gear plate, it shows it's used, and you have to go here, used with TVC. Well, in our example, we're not using TVC. That's not going to be the gear plate. The third gear plate is used with preset counter. We're not using a preset counter. That's not going to be the one either. The third one we'll look is the G2674. It's got a special node called 2%. Generally, when a 2% gear plate is used, it's used on our LPG meters, or with some meters with undersized rotors like class 8 meters or class 14 meters possibly. So this is not a case either, since we have a class 1 meter. So the only gear plate that would work is the last one, G2681. You see a whole bunch of information across, but for us, probably one of the more important things is that this gear plate requires 2-to-1 ratio. So if you're doing any field conversion and that your meter has a 1-to-1 ratio, you would have to change it to 2-to-1 ratio. It gives us what the ratio of the gear plate is here, 1.8387. That tells you that's the output ratio of that gear plate. And also gives you, if you decide to build your own gear plate, it gives us 3 gears that go into this plate, which is gear of a size as 31, 46, and 57. The last number is just a reference drawing number, so it's not important. But those are 3 gears that go into this gear plate. So again, it's a big manual with a lot of information. I just scroll through it, and you can go through meter sizes and find pretty much any gear plate that you would need. Now, again, just a word of caution. If you're not sure which to use, just give us a call. But this gives you a pretty good reference. Let's see if I can close it. And are you back? Are we back in the presentation?
Yes, Tom, you are. Thanks.
Okay, cool. Thank you. So again, a lot of information about the gear plates, but again, I'll go back to one screen back. This is the most important part. You have to match the gear plate phase gear ratio and a meter and a unit and a units of measure you're measuring in order to be able to measure accurately. Again, I'll just repeat the definition of calibration, and then we'll see. It's a process or procedure of setting or bringing meter into agreement with whatever standard we wanna we need to use. The combination of the meter, gear plate, counter, phase gear ratio, again, puts you in a ballpark, puts you where you need to be in order to calibrate or do fine tuning, or in order to make the meter repeatable, to make the meter accurate. Now, in calibration, there are really two type of tests. One is a normal test, which is normally done for accuracy and repeatability at the highest maximum discharge rate. So let's say if the meter is M7 and it's rated for 100 gallons, that meter often will be used close to that flow rate, maybe at 70, maybe in 80 gallons. So you would be calibrating and checking for accuracy of that meter at that flow rate. Generally, that normal testing is done with a temperature compensation if used to being turned off, either mechanical or electronic with turn off mechanical compensation, and all the normal testing is done in a gross mode, with temperature compensation turned off. The special tests are any other test performed on metering system. There could be a number of them, from low flow testing when you're checking for linearity of the meter. It could be a split compartment test, also called a depletion test, or any other test related to that metering system. So normal test and a special test. Question that comes up very often is, how frequently do we calibrate? Liquid controls, it's not necessarily a governing body as far as the frequency of calibration. We generally recommend that meters should be checked annually, or often as the application requires, which means if the meter is used very often and a large volume of the product goes to the meter all the time, that meter may have to be checked more frequently than once a year. Generally speaking, our meters will hold the calibration for a year as long as the product is fairly clean. If the product is not very clean, the product or all the sediments or all the debris that's in the product will move through the meter with a liquid, causing, let's call it erosion of the surfaces of the meter. As a result, you will see the increased clearances inside of the meter, and with increased clearances between rotors and the housing and the bearings, you're going to see the increased slippage of a product through the meter. Increased slippage will call for, it will create inaccuracy and a call for recalibration. So really, we don't tell how often, we just recommend once a year. As far as the whole process of calibration, that's generally defined by API, and frequency is often defined by any regulatory bodies, local bodies, so being weights and measures, UAS weights and measures, or local state or even other governing body. Wherever that meter is operating, whatever governing body is in that location, that's who determines frequency of calibration. Now, again, all the components, assuming they are correct, will put a meter in a ballpark or close to being accurate. But every meter has to be, like I said at the very beginning, field calibrated and adjusted to make sure it's accurate to meet all the requirements. And device in a meter that allows us to do that is an adjuster. This is an adjuster right here. Again, a lot of people call it calibrator. A lot of people call it micro adjuster. It is really a variable transmission that allows us to adjust meter reading very precisely. If you look at this adjuster, again, there's a hex shaft going up to that the adjuster that would drives the adjuster. And on the top of it, oh, maybe I'll change this. On the top of it, its output, that's what's gonna drive a counter. in a very basic terms, again, it's a transmission that allows us to change output speed that goes into the counter. And we can change this output speed very, very precisely to adjust the calibration, adjust accuracy of the meter. To change the adjustment, you need to really do two things. Loosen up this little screw on the side that locks, that clamps that adjuster and prevents it from moving when it's being used. Once that clamp screw is loose, the thimble that's on the bottom turns both directions, turns clockwise and counterclockwise. You can see two scales here on the adjuster. There's a vertical scale that goes 0, 1, 2, all the way to 5. Each increment between a 0 and 1 and 1 to 2 represents 1%. So when we turn the thimble either direction from one number to another, make full revolution, we change the speed of output speed by 1%. As a result, we would change the reading on a counter by 1%. The horizontal scale represents, the numbers represent 0.1%, and the hash marks between the numbers represent 0.02% of error. So it's a very, very precise device. We can adjust a reading of a counter by as small number as 0.02%. We're making an adjustment. Now again, that adjustment moves up and down on a scale. It can go close to 0 or close to number 5, which is at this point not visible. It's a little bit below. So how do we make that adjustment? How do we know which direction to go? How do we know by how much? Well, it starts with the process of calibration. And again, we'll use example of a prover. So we would normally remove the cover, expose the adjuster, and we'll make deliveries to the prover. We'll probably make more than one delivery. Normally, the first delivery it's called wet down. That's you discard that delivery and then make a number of deliveries to check for repeatability. If repeatability is there and you are off, we can now calculate how far off we are. The simple formula that allows us to calculate percentage error or percentage of correction is volume in a prover minus volume indicated by the meter and divided by volume in a prover. If we multiply that number by 100, that's going to give us a percentage error. Now, what do we do with that percentage error? Well, it depends. There are really two scenarios. If the prover volume, so volume delivered, is less than volume registered by the meter, we would add percentage error to the reading on the adjuster. Now, what is the adjuster reading? If you look at this adjuster here, and you see when those two scales are crossing, we're right at 2.3. That's our adjuster reading. If our percentage error, let's say, is 0.5%, we would take 2.5, and in this scenario, we would add to it. So 2.5 plus 0.5%, our adjuster reading would be 2.8. We would have to take the thimble and start turning down towards a setting that's 2.8. The only comment I would make here is that anytime you go down in a scale, you want to go past the set point. So if we want to set it at 2.8, we want to go past that point and then come back to 2.8. Again, it is important because of the design of adjuster that you go past the point and come back to it. If we look at a second scenario, when a prover volume is more than a counter, now we want to speed up that counter so it turns faster to indicate what's being delivered to the prover. In this case, we would subtract percentage error from adjuster setting and turn that adjuster up towards 0. there is a number of ways of memorizing how to do that. My way, personal way, always was that if I want to speed up the counter, I want to go up in a scale towards 0. If I want to slow down the counter so it counts less, I go down in a scale towards 5. That was my way of memorizing that from day one. But I think this is pretty good explanation how to calculate it and which direction you go. Once you calibrate it and you're accurate and you're repeatable, you would take this clamp and you take this screw, tighten them up, and that's your final setting for adjuster. Now you can do other testing, any other either linearity testing or any other testing using this already calibrated, accurate, and repeatable meter. Very briefly, since we're approaching already 10 o'clock, very briefly, there are a number of methods of calibration. I will really, one of the more common is volumetric proving. That's something that's especially common here in the United States. That may vary depending where you are in the world. Volumetric proving is fairly simple, but very accurate. You need, again, a prover or a vessel of a known certified volume. So let's say 100-gallon prover. We're going to be pumping a product through the meter to that prover, filling up a prover, and really comparing volume delivered in a prover to the volume registered on a meter. And then once the volumes are compared, we can go back, calculate our error, and make adjustment on a calibrator. There are some important things when you're using a volumetric prover. I talked earlier about weighting down prover, make sure that provers come to the temperature of the liquid, make sure the system is full of liquid. So you close the valve, you engage the pump, you charge the system, and then reset the counter. You want to make sure that you start your calibration process with a register indicating 0, and then again, fill up the prover, make the readings, and make the adjustments. And again, you may have to make multiple runs in order to check for repeatability, make adjustment, change the calibration, adjuster setting, make the meter accurate, and test it again for repeatability. It's a very simple process in a way. It gets a little bit more complicated, maybe especially on LPG, when you're dealing more with pressures, temperatures, and other factors. But this is not a class to teach you how to calibrate exactly. Those are generally defined by either local authorities or some of that is in API documentation. I'll give you just one example of how would you calculate the error out of this, out of the prover run. But before we get there, question also that comes up or often, how big the prover should be. This is really a point from what's called Handbook 44. That's one of the guidelines here in the United States defining a calibration. And generally, that test draft or a size of a prover should be at least a volume that can be delivered through the meter that's being tested in 1 minute. So if you have a meter that is rated for 100 gallons a minute, if you pump a product through it for 1 minute, you're delivering 100 gallons, and that's is the size of a prover. We're seeing often that on the field, proving is done with a much smaller devices, and generally that's going to create a lot of problems, not only from accuracy but repeatability standpoint, because most of the time you're not really running even a full flow of the meter when your prover size is 5 gallons and your discharge flow rate is 80 gallons a minute. There's no way of making it an accurate way. And again, calibration, we use example of 200-gallon prover. We've filled up that prover to 200 gallons. We make the readings and we find out that prover is 76 cubic inches less than 200 gallons. Registered to 199.4 gallon with adjuster setting at 3.06. So first thing we're going to do is convert the cubic inches to the to gallons. So 76 cubic inches divided by 231, that's the number of cubic inches in a gallon, equals 0.33. So 200 minus 0.33 gives us a prover reading of 199.67. Now we have a prover reading, we have a meter reading, we can calculate our error, which ends up being 0.14%. Since the prover is reading more than a meter, we're going to take current adjuster settings of 3.06, subtract our error, giving us new adjuster setting of 2.92. Again, I go fairly fast through it, but it's fairly simple calculations. The other methods of calibration could be by weight. That method of calibration is used often on a viscous product, even here in the United States. Filling up a prover with a very heavy oil is easy. The draining of that prover, it's almost impossible. The product will cling to the walls of a prover so much that you will never empty that prover completely. So using a scale is a better way of doing this, where you weigh the product and then recalculate it into volume and compare the volume in a scale into volume in a meter, and you make correction the same way as you would with volumetric prover. Third method that is fairly common in certain part of the world is master meter proving, when a meter of a known curve, of a known performance, is used as a reference device. So you're really testing a meter against another meter, and that meter is of a known performance. So you know what the percentage errors are at specific flow rates. And again, the process is very similar. You're comparing value of the tested meter to the master meter. Again, it is 10 o'clock. That kind of concludes this part. I know it's fairly fast, so I'm not sure, Jeff, if we have any time for questions or any questions in the chat room that we can quickly answer, or you've been answering them all.
Yeah, I answered a couple here.
Okay.
We can open it up here for a second while we transition over here to Bill.
Okay.
Anybody has any questions? And while you're doing that, Tom, if you want to go ahead and release the screen, and then Bill, if you're on, you can jump on and share your screen.
All right.
Any questions out there while we're transitioning here?
Bill, you should be ready to go. I stopped sharing my screen.
All right. So the nice thing is my presentations here are going to be extremely short. I am going to have some hands-on demonstrations here going through these different registers and on how to actually use them to calibrate with. Tom did a great job of explaining what calibration is. And in these presentations here, we're going to go ahead and show you how to really calibrate these meters. So the first one that we have is an LCR 600. Then we're going to go through the LCR2 using the lap pad, and then also using the select and increase buttons on the front of the register without the lap pad. And then finally, we're going to go through the LCR IQ and show you how to actually calibrate that. So the first thing that we want to do is we definitely want to put the register into a calibration mode. And in order to do that, you're going to have to go ahead and remove the switch plate. Let me get to my camera here. Okay, hopefully everybody can see that. I had to do a little bit of a diagonal here so that way I can get the light out of the way. But what I was talking about here is there's a switch plate that goes around here. So you're going to have to take those 4 screws off, and then your next event is going to go ahead and turn that red knob straight up and down. You'll see that the red knob on the 600 and the LCR2 has a little white arrow on it here, a little white line on it. That's the one that we want in the 6 o'clock position. Once you do that, you're actually going to get a calibration ticket to print out. It'll look just like this. Okay, so you're going to have the calibration ticket number, event number, configuration number, and all the calibration factors on there. So that's the first thing to go ahead and do that. So once we get into calibration, you're going to see the configuration menu start up. What we want to do is we want to go ahead and arrow up, and all I'm doing is hitting this up arrow button into the calibration setup menu. Go ahead and hit the enter key, and we'll actually enter into the calibration setup. Now, in order to start calibration on any of these electronic registers, they do need to have a starting K factor. Most of the time when they're from the factory, they're going to start out at a default K factor of 20. So in order to change it, let's say we want to have something closer to an M7, which is going to be somewhere around 2200. So if we just enter in 2200 pulses per unit, in this case, pulses per gallon, that'll get us pretty close to start with. Let's turn the light off here, see if you guys can see that any better if we do it this way now. There we go. It looks a little bit better. Okay. So now what we can do in order to start a delivery, now that we've got a beginning K factor in there, with the LCR 600, it's very simple. All we got to do is just go down to this line that says begin calibration delivery and then hit the enter key. And what it's going to do is it's going to go through, it's going to give us a counter test, and then it's going to go ahead and we're going to fill our prover up. Okay. Now we're flowing at a very slow flow rate because of the large K factor that's in this. So I'm not going to let it go too awful far, but depending on the meter that you have, that's going to determine your draft or your prover quantity or your prover size that you're going to want to be using. So so we'll go ahead and we'll end this calibration delivery here, and we'll say, okay, so it was set at our prover quantity down here. This is what was actually on the register. So let's say in this case, the prover actually said 0.700. Okay, so we were a little bit under. What we would do is we would just go ahead and arrow up to our prover quantity. We would go ahead and hit the enter key. Then we would go ahead and back up over this. So all I'm doing is just hitting the up arrow once, because now we're going to get the little over arrow. And then we can enter in 700 using the keypad on the front. And then go ahead and hit your enter key. Now, if you noticed, on our pulses per unit, it actually changed it on its own. Okay, so we didn't have to do any kind of calculations or anything like that. Once you actually enter in the prover quantity, it'll go ahead and start that deliver or adjust your pulses per unit for you. In this case, this is in gallons, so we're looking at 2,090 pulses per gallon. So again, let's do this again. Let's start back at 20, so we can get a better proving run. So we go down to begin calibration delivery. Go ahead and hit the enter key. We get a counter test. And now we actually make a delivery. And before we start making these calibration deliveries, one thing you always want to make sure that you're doing is that prover is already set to 0. Okay, so you want to make sure that the prover is zeroed out before we start these so we get an accurate one. So let's say on this one, we stopped our delivery at 52.25. Let's say we had a 50-gallon prover and we had 50 gallons in there. So we're going to go ahead and we're going to change this to 50 gallons. And you always want to make sure that this prover quantity is what's in the prover, not what's on the display of the register, but what's actually in the prover. So we enter that, and again, you can see now our calibration factor has changed. Okay, now if we take our red knob and we go ahead and we come back out of calibration into the stop position, you can see the red knob now is in our stop position here. And if we look at our calibration ticket here, there's our new calibration ticket. So you can see now we've got the 2090 or 20.90 in there. So now we've actually gone ahead and we've calibrated that meter. So again, it's pretty simple on an LCR 600. Show you guys how to get back into it one more time here. So if you are in the main screen, let's get back to the main screen where your delivery screen is. So this is kind of the screen that you're used to seeing.
Hey, Bill. Hey, sorry. Yeah,
let's see
I have a real hard time
let's
seeing
see
it.
if we can.
There you go.
There we go. Okay, so you're back in the main delivery screen. Your red knob's in the stop position. So in order to get back into that calibration screen, again, red knob in the 6 o'clock position, you'll come up to the configuration menu, arrow up or arrow down to the calibration setup, hit your enter key, and then you'll be in calibration setup where you need to go ahead and start your deliveries for calibration on the 600. Okay, so that pretty much is as easy and as quick as it
Hey,
is
Bill.
for, yeah.
Hey, quick question, and I know this comes up a lot, is, if I need to do multiple calibration runs, should I be going in and out of calibration for each run? Or should I
It's a
just be
good
saying,
question. Good question, Jeff. Yeah, when you enter calibration, until you are happy or satisfied that your register is within your tolerance, you should always be keeping the red knob in 6 o'clock position. The reason being is if you go ahead and you make a run and then you come out of calibration, that proving run is basically going to be void. You're not going to be able to enter in the information into that prover quantity field. So this red knob is always going to stay in the 6 o'clock position, and you can run multiple calibration runs in order to get where you need to be as far as your accuracy on your meter. So yeah, great point. And I do see that from time to time where somebody's trying to calibrate a meter and they're using a red knob, go up into the run position, they get their counter test, they go ahead and fill their prover up, and then they go down to the 6 o'clock position, but then they can't enter the prover quantity. And that's because when they started that delivery, it was never in calibration mode. So yeah, good point there to make sure that you keep that red knob in that 6 o'clock position throughout the entire process.
yeah, and the other point I was going to make here, also, if I can jump in, is that, obviously when Tom was doing his presentation and there at the end, he was showing you all the calculation that's being done to figure out what the percent error is and to make the adjustment on a mechanical adjuster. The beautiful thing about the electronic registration is all that functionality is built into the register. You're really just entering in what the prover quantity says, whatever the figured prover quantity or master meter volume was that went through the meter. You're just telling that information into the register, and it's doing all those calculations that Tom was showing in his presentation. It's doing that all for you.
Exactly. Yeah, it's doing all the background math for you. So all you got to do is worry about putting in the correct prover quantity, and that's really all you need to do.
Right.
All right. So moving on to the LCR2. All right. So we're actually not going to talk too much about multi-point calibration here today because that could be a discussion that can take hours just on its own. So we're going to go ahead and we're going to talk about calibration of the LCR2 with the lap pad, and then calibration of LCR2 without the lap pad. And for any of those out there wondering about calibration with the 600 on the lap pad, keep in mind that the LCR 600 does not have lap pad functionality. So you can only calibrate the LCR 600 through the front display and keypad, or you can use Easy Command, which I'll show you here towards the end of the hour here, how to use that. So again, let me move my camera over here so I can get a little bit better view here. But again, we have to remove that seal, and then also the switch plate. So those are going to have to come off as well. So we've got our switch plate here for the LCR2, our serial wires and all that stuff. So this is going to have to come off. And then again, I think Tom showed something similar to this as well. We've got some starting K factors that are out there for some different meters that we can use. And the way that we measure this 2,222 pulses per gallon, if you remember, the meter puts out on an M7 meter, it puts out 5.55 gallons per revolution. Well, on any of our electronic registers, we use what's called a quadrature pulse output. And those quadrature pulse output devices for our pulser puts out 400 pulses per revolution. So if you take the 5.555, multiply that by 400, that's how we get this 2,222 pulses per gallon. So that's how we come up with a starting K factor. And that is based off of a 1-to-1 packing gland gear ratio. Most of the electronic registers as they leave the factory will be a 1-to-1 packing gland gear ratio. Now, it's not to say that you can't use a 2-to-1. A lot of times on a mechanical to electronic retrofit, you'll see a 2-to-1 packing gland gear ratio on the mechanical meter. Well, you can use the same packing gland gear ratio, but what you're going to wind up doing is cutting that K factor in half. Okay, because we're actually going to be putting out less pulses per gallon, so we want to cut that in half. So just keep that in mind when you're doing retrofits. So what we want to do is, again, it's going to be the same kind of stuff. We're going to go ahead and we're going to use the lap pad here first. So let me go ahead and let me get my camera here so that way we can see what we're doing. All right, so here we have our red knob. Let me move this up just a little bit. At least we don't have to worry too awful much now about the glare on this one. So we've got a little bit more of lighting is a little bit better here. So you can see, let me go ahead and move my printer over. On this guy. And the calibration tickets for the LCR and the LCR 600 are going to look pretty close. There you go. So let's print out and I'll go back down in calibration here and I'll show you what that one looks like. The only real difference in these calibration tickets are going to be some of the software that you see. Okay, so here is calibration ticket for an LCR2. So it looks pretty much identical to an LCR 600. The one thing is on the 600, if you do have POS active, you're going to print out the full 16 products. So you're going to have a much longer ticket on an LCR 600 with POS active. Okay, so in order to do it with the lap pad, let's get the lap pad here first. So what we want to do is we're in calibration now. The red knob is straight down. So what we want to do is we want to go ahead and scroll over until we see product calibration. So we're in product calibration. We go ahead and hit the enter key. Hit the M pound key. The M pound key right here. That'll get us to the next one. And the next one. Here's our approver quantity. So this is really where we want to kind of be throughout this whole process. And in order to start a calibration delivery with the red knob in that 6 o'clock position, all we have to do is go ahead and hit the enter key. Oops, sorry, not the enter key, the start key, sorry. And we should get a counter test in progress. And now we'll go ahead and we'll fill up our prover. let's say our prover in this case is only 25 gallons. So when we get to the end, we want to hit the print key. Print key is down here. This is how we end our calibration delivery. Then what we want to do is we want to arrow over to the prover quantity. And one thing about using a lap pad, when you're using the lap pad in order to enter information, we have to make sure that we're getting a flashing cursor here. Okay, this allows us to drop down by hitting the enter key. So that way we can actually enter in the information. So let's say we had a 25-gallon prover and we go ahead and hit enter. And now you can see our pulses per unit changed on by itself there. So by putting in that prover quantity, it changes your pulses per unit to what you want to do. So if you wanted to make another run, all you would have to do is hit the start key. We get a counter test. Or go ahead and we're delivering our prover quantity. When we're ready to stop or when the prover is full, we will go ahead and hit print to end the delivery. And we've got a prover quantity there. We would hit the enter key and we would say, okay, we have a prover quantity of 20 gallons. Hit enter. And now our pulses per unit has changed again. So that's kind of how you would go through using the lap pad on the LCR2 itself. Now, in order to change products too, if you have multiple products, the LCR's got 4 products that you can calibrate. What you'd want to do is you want to make sure that you're over on the little pound sign, hit the enter key, and then use the arrow keys to change your product number. So now you'd actually be in product number 2. There's product number 3, product number 4. So that would be how you can change different products in order to calibrate them. Okay, so to use the front of the register, let's make sure everything's tight here. So let's cycle through this real quick. So you've got a standard display here, and hopefully everybody can see the select and increase buttons there. There's a little bit of a, there we go. That looks a little bit better, I guess, without the light. So you've got your select and increase button, and the select and increase button, we can go ahead and we can use that to prove. So what I'm going to do is I'm going to go ahead and unplug my lap pad. My lap pad's unplugged. Now I just have a standalone register hooked up to the printer. Again, take your faceplate off, red knob in the 6 o'clock position with the little white line down towards the bottom. So you hit your select key, it's going to flash. Okay, this is telling you, this is asking you what product you want to deliver. Now, if you look, I'm pushing the increase button, but it's not going anywhere. The reason for that being is because I've only got a K factor in one product. So it's only going to allow me to calibrate those products that have a K factor in them already. So if you are calibrating more than one product and they don't have a default K factor in there, you will absolutely either need easy command or you will need a lap pad in order to set a default K factor in those products. Okay, once you have a default K factor in their pulses per unit, then you'll be able to go ahead and cycle through the different products using the increase button. But in this case, we've only got product number 1. So we will go ahead and select it. Now you're seeing your flow rate. Okay, since we aren't delivering anything right now, our flow rate is at 0. If we hit the select key again, now we're going to get our temperature. Now this one doesn't have a temperature probe installed, so you're going to see this 999.9 degrees Fahrenheit. And if it was in Celsius, you just see the Celsius sign there instead of the Fahrenheit. So you go one more, and then you go back to your counter. So in order to start a calibration delivery, once you know that you're in the right product, no flow rate, there's your temperature. All you have to do is hit the increase key. You'll get a counter test, and then you'll go ahead and start filling up your prover. So once you are done with your prover, let's say it gets filled up. Let's say it's a 25-gallon prover here, and you hit increase one more time to stop your delivery. Okay. What's going to happen here is, in this case, your far left-hand digit is going to start to flash. This is indicating that it's waiting for you to enter in what's in your prover. So let's say we've got 25 gallons exactly in our prover. So we want to put 25 gallons in there. So in order to change the numbers, all you have to do is hit the increase key to cycle through the numbers until you get what you want. Okay, so in this case, we're going to put 25. So 0, we're going to leave the 2 alone. We're going to leave the 5 alone. And then we're going to change this 187 to 0. So we just keep going all the way around until we get to 0. And then once we get to 8, turn that one to 0. And that last one. Now, just a bit of caution. If you do enter these digits wrong and you go to the next one, there's no way to go back to it. So be very careful when you're entering these numbers to make sure that they're correct before you hit the select key to move to the next one. So now once you do this and you hit the select key, now let's go back to 0. Once you hit select on that last flashing one, basically that is entering your prover quantity into the register, and it's doing its calculations behind the scenes. So that's really as easy as it is using the front of the register for this. Again, if you want to make another run, let's say you're off a little bit, just hit the select key or the increase key. We go ahead and we do a counter test. It goes ahead and we fill up our prover. Once our prover is full, we want to go ahead and hit that increase key one more time. Then we want to go ahead and change our number here to match exactly what's in our prover. And then hit select at that last one, and that'll actually lock in our prover quantity. So that's a little bit about the LCR2 with the lap pad and without the lap pad for calibration there. So the last register that we've got here, let's hopefully we can see this without being too shiny.
Are you able to turn the brightness down on this display?
Yeah, I've been playing with this all morning to try and get it a little bit. I can get it if I go close enough to it. Should be able to see it a little bit better here.
Hey, is there a way to maximize that window, or is it already maximized?
This is, let's see.
Up in the top.
It's as big as it goes right now.
Okay, all right.
Yeah, I was kind of hoping that we could get a little bit bigger screen on here, but that's about as large as it'll go. So let me switch the printer over because I've got a no printer status here for this one. So let me go ahead and switch this real quick. All right. For the IQ, it's a little bit different as how we get into calibration. Let's see if I can show this on the downside here. If you see this, there's this little screw right here. What you need to do in order to put the IQ in calibration is just go ahead and unscrew it about a 1/2 inch or so. But what you're waiting for is you're just waiting for it to go into calibration. Okay. There we go. Okay. So once we are in calibration, it's pretty much the same process on the IQ as it is for the LCR2, just a little bit different as far as the keystrokes and the menu. So once you get into the main menu here, you see main menu up at the top. We want to go into the setup menu. So you can hit the up arrow once to get there. Hit the OK key, and then you're going to be into the setup menu. What we want to go to is in this calibration menu right here. And once we're in here, now you can see, now we've got a lot of the same information here. We've got our standard pulses per unit here, pulses per gallon, 1400. So we've got a starting K factor in there. And then here's our approver quantity field right below it. So in order to start a delivery, you can see on the lower right here, we've got a little a button basically that says run calibration. So what I'm going to do is I'm going to hit the little function key that's right underneath run calibration. And it's going to go ahead and go to its delivery screen and start a delivery. It's given us our flow rate. We're getting our temperature. Okay. Once we're done with this calibration, and you'll see a calibration delivery active up at the top. Once we have filled up our prover, all we have to do is hit the button right below end. And it'll take us right to our prover quantity. Okay. And in order to enter that, all we have to do is hit the OK key. We can go ahead and let's say it was a 45 gallon prover. So you put in 45 gallons. That's how much is in our prover. So we actually ran 45 gallons into the prover and go ahead and just hit OK. You can see now it changed our pulses per gallon based off of the prover quantity and the difference between what we actually delivered. And then again, if we want to run multiple calibrations, we want to make sure that that screw stays in calibration mode, just like we do with the red knob. So if we wanted to run another one, we go ahead and hit the start calibration or run calibration. It'd go ahead and start for us. And we would go ahead and hit end. Takes us to our prover quantity. Hit the OK key. Clear that out. Enter in exactly what our prover says. So let's say it was 12.12 gallons in our prover, and we would hit OK. And again, then it would change our pulses per gallon. The IQ calibration ticket's going to look just a little bit different. It has a lot of the same information on it. Let's see if you guys can see that a little better. There we go. There we go. So you can see it's got a lot of the same information on it. In this, there's only two calibration or two products that are calibrated, so it's only going to print those two on the ticket itself. So that is one difference between an IQ and an LCR 600. Let's see, maybe we can look better this way. Yeah, so in this one here, we've only got two products calibrated that actually have pulses per gallon set up in it. So it only prints off what is actually has K factors in them. So like on the LCR 600 and the LCR 2, it would print out all four products on the 600 if it did not have POS active, whether there's a K factor in the product or not. Same with the LCR 2, it would print out all four products on your calibration ticket, whether or not there's a K factor in them or not. But on the IQ, it will only print out those products that have a K factor in them. So because of the fact that we've got up to 16 different products that we can calibrate, it'll only print out the ones that are there. Okay, so let's see if we can switch over. We got about a half an hour yet. Let me see if I can switch over real quick to easy command here. Show you guys a little bit about the easy command, and let's just do an LCR2. Give me a second to hook everything up here. Okay, so here's our easy command. So now we're connected to an LCR2. Same rules apply. That red knob goes into the 6 o'clock position, and we'll stay there throughout the duration of our calibration. So what we want to do is we want to go ahead and connect to. First, we got to go to set up communication. We got to get a port name here. Okay. Try this one more time here. Maybe we got the wrong port. There we go. Okay. So once we're connected, it will give us status of our red knob. So in this case, it does show that it is in the 6 o'clock position. And let's see if we can. We need to go over to the calibration setup. So it kind of mimics the lap pad. Okay, so we've got the same information. So in order to begin a calibration, all we want to do is just go ahead and hit this begin calibration. We should see the counter reset. And now we do have a delivery going on, so you can see that we are counting up. When we're done with the delivery, when our approver is full, we would go ahead and hit the end calibration button down below. This allows us to go ahead and put in our approver quantity right here. So let's see, we got a 30.000. And then what we want to do is we want to hit this apply to LCR down in this corner here. And if you watch, our 27.27 should change. So again, if we want to start a calibration, hit begin calibration. We go ahead and fill up our prover. End our calibration. And you'll see the prover quantity unlock. Oop. And then that'll change our K factor. So I think that's pretty much all that I had to show today. We actually finished a little bit early. I don't know, Jeff, if we want to open it up for some questions now.
Absolutely. So appreciate that. Thanks, Bill. So if you have questions in general, again, we'd be happy, whether it's on mechanical or electronic calibration. If you want to unmute yourself and ask questions, or if you want to text questions to us, or again, if you don't feel comfortable doing it in the group setting, you're welcome to send it to us separately. But we'll go ahead and open it up now for any questions that you might have. Well, if we don't have any questions, we'll hang out here in the Teams meeting here for a little while. Please feel free to ask any questions. We'll be here for at least another 5 minutes. We'll be glad to answer any questions. But if there aren't any other questions, please enjoy the rest of your morning, afternoon, evening, depending on where your time zone is. And again, we look forward to seeing you at some of our other trainings. Don't forget, July 7th is going to be the meter accessory class. And then July 21st will be strictly focused on LCR 600 installation, setup, and operation. So again, please feel free to join us for any of those classes. And if there's no further questions, please enjoy the rest of your day, evening, and we'll talk to you soon or see you in the next class.
I want to go back. I do want to go back real quick, Jeff, to kind of point something out here. Before, when I was doing easy command, after I had put in approver quantity, I hit the apply to LCR.
Mhm.
Well, what you actually have to do is you have to hit this change button instead of the apply to LCR. So let me
Yeah.
go through that again. So when you begin a calibration delivery, you'll see our delivery up in the LCR status. And you want to go ahead and end calibration there. So let's say our approver was actually 10 gallons. When you enter in your 10 gallons, it should light up this change button. Now, let's try this again. Okay, so let's go ahead and let's begin a calibration. And again, this will be the same on the LCR 600 as it is on the LCR 2. And then we want to hit the end calibration. And then this will allow us to get into the approver quantity. And then instead of hitting this apply to LCR, hit change. You'll see the K factor change. You can see it change there. If you do the apply to LCR, it will not change your K factor. So make sure you hit the change button up here, not the apply to LCR. So if I go through this again, go ahead and end calibration. And instead of hitting the change here next to the approver quantity, I hit apply to LCR. If you watch, it won't change my K factor. So make sure that you use this change button instead of the apply to LCR when using the easy command for this. So just wanted to make sure that that was clear.
Thanks, Bill. And remember, so as part of this university setting that you guys are all signed up for, we do record each one of these sessions. So this session is recorded, as well as we had a training session. I think one of the very first training sessions we did in this series was specifically on Easy Command. So if you're seeing Easy Command for the first time today and thinking, that's a program you'd like to try, I'd recommend first you start off by just going back through the video sessions that are available to you by signing up for this class, and you can review the Easy Command application as a whole. Also, I think, Bill, you're still planning on doing a deeper dive Easy Command lesson on how to load that software also. So we'll look to plan another class just really deep diving on how to install LCR or Easy Command to your PCs. That's more for technicians that are looking to load the software the first time onto a laptop.
Yeah, I think we've got I think there was a video on loading it up, but yeah, there's some specific things that we need to get a little bit more deeper in on Easy Command and future trainings, as far as flashing LCR2 boards, and also the older LCR2 boards using the SR210 software, which is something that we don't see a lot of, but there are still quite a few of those LCRs out there that take that old LC or the old SR210 software that we have to go through a different process to load that with Easy Command. So, and then also the LCR 600 flashing, and then of course the LCR2 itself. So, we're talking about these different tabs here for loading software that'll come out in some future training classes.
Great. Thanks, Bill. I see a question from Keegan. Hi, Keegan. So where do we find the previous videos for the series? So, and Dan, you can jump in if I get this wrong, but I believe early on or when you signed up for the class, you should have received a follow-up email from Liquid Controls that had a link for you to sign up for a one-time thing to basically have access to the university videos. Once you have access to the university videos, and Bill, I'm going to kick you off here real quick.
Okay, go ahead.
I'm gonna grab the content here. So let me share my screen. So hopefully you can see my screen now, which is pretty boring here. Let me just open up. Actually, I'm going to show a couple things here. But let me start with going to the Liquid Controls website. So if you're not familiar with Liquid Controls website, www.lcmeter.com is the easiest way to get there. Once you're on the website, if you signed up for the class and then you followed that link to get access to the training videos, in the resources tab here on Liquid Controls website, you'll see LC University training videos. If you're going there for the first time, you'll have to enter in that code that was sent in that email. But once you've entered it for the first time, you'll always have access then to the LC University training videos. And on here, you can see all the ones up through June 9th have already been put out here. So all these different links, if you click on the link on the screen, you can get to any of those videos. So the first one we were just talking about here is the Easy Command Intro Basics and Flashing. If I was to click on that, that's going to take me right to YouTube, and after the ad, it'll jump right to that training session that's out there. So you can see this is the training session we did for LCU. So hopefully that answers Keegan's question. The other thing I was going to point out, the guys during the training here were talking about calibration factors. When the LCR IQ came out here 2019, I went through and revised that K factor list to include all the different models that Liquid Controls was supporting at the time. So the Liquid Controls M and MA series meters, MS series meters, and the Avery Hardall meters. So we do have an updated chart that gives you all the different calibration factors and pulses per unit and pulses per gallon that are out there. If you want to find this chart, the best place to find it is in any of the LCR IQ documentation, because we did update those documents to have this in there. If it's something you're looking to have, we can also just email you this spreadsheet too. So if it's something you're interested in having, we'd be happy to send that to you. So just wanted to jump in and share those couple things. Again, I don't think we have anything else for you today. Dan, looks like you put something up there. Was that a link to the university?
Yeah, that was just a link to the log, or the same place that you just showed us there, Jeff.
Okay,
but yeah, so those that might not know what we're talking about in terms of the link, for those that signed up early on, we would have already provided you an email request to go ahead and set up your login for the LC University area. If you signed up later, like within the past 3 weeks, you would have automatically gotten an email after your sign up that gives you the ability to go ahead and log in. So if you have any questions, of course, you can just email us back, and we'll be happy to help you guide you through it.
Thanks, Dan. So are there any other questions out there? We'd be happy to hang out here for a little bit and address any concerns or questions you have. I guess one other topic is, if you go through the videos and you've attended a lot of classes, if there's some subjects you maybe are interested in learning more about, please feel free to send a message to myself. If there's a topic that we're missing or that you're interested in, we'd be happy to consider other topics as well. We're in the process right now of determining the kind of the second wave of classes here that'll begin either in August or September, depending on our schedules here. They will be heavily focused on the IQ register.
I got a question.
That was interesting. I just got muted. As soon as those schedules are out there, we will let you know. So sorry, I heard someone say they had a question.
Yeah, this is Dave Cox with Tico.
Hi, Dave.
Hi. Hey, I need to know if you could email me the part numbers for the LCR IQ register and there's a computer for the cab, for inside the cab, like a laptop computer. Do you guys? I didn't see that being discussed today, but.
Well, Dave, I mean, obviously we supply the registers, but if you're talking about like a third-party computer, like that a customer's using for doing deliveries, something like ad systems or one of those other third parties that are out there, we don't provide or sell those. The only application we really have is what Bill was just showing you, which is our Easy Command, which is more of a tool for doing setup and things like that. As far as getting part numbers for IQ, I can get. You said you were with Tico, right, Dave?
Yes.
I'll get with your regional manager, and he can get with you on getting you whatever pricing you're looking for with regard to the registers. That's never a problem.
Okay.
All right, I'll make sure I contact him. I'm looking to see if he's on the class here today. I don't see him out there.
No.
But I'll get with the regional manager, and he can get in contact with you.
Yeah, just one note too about Easy Command and the IQ. You can connect Easy Command to the IQ, but because of the fact that LCR or Easy Command was designed more for the LCR2 and the LCR 600, a lot of the fields in the IQ are not available through Easy Command. So just keep that in mind if you're thinking about doing calibration with Easy Command. You're probably going to have a rough time. So just use the front of the display and the keypad on the IQ rather than Easy Command, because it really wasn't built for that.
Thanks, Bill. Do we have any other questions out there? If there are no other questions, again, we're done presenting, so we'll hang out here for a little bit in case there are some further questions. But otherwise, again, I'll say please enjoy the rest of your day or evening, and we look forward to seeing you again soon.